If you are starting your journey into natural language processing, this video is for you. We will break down the basics of natural language processing and we will deep dive into different fundamental blocks of how NLP pipeline is built, what are different concepts like word embeddings. We will explore vectorizers like TF-IDF, and we will dive into embedding models like Word2Vec. NLP focuses on enabling computers to understand, interpret, and generate human language. It combines linguistics, computer science, and machine learning to bridge gap between human communication and machine understanding. There are different keywords that are used in NLP and key tasks. The first one is tokenization. Tokenization is nothing but a splitting up of text into smaller units like words, subwords, or characters. Just for example, here we have AI is powerful. In this particular sentence is broken down into three tokens. That is, AI isn't powerful. Text preprocessing. It's a very important term in NLP, which involves cleaning and normalizing text. For example, lowercasing all the characters, removing stop words, stemming, and lemmatization. We will cover the details of these keywords later. Part of speech tagging. This is more advanced key term where it with libraries it identifies grammatical roles in word in a particular sentence with respect to whether it's a noun, verb, adjective. Named entity recognition detects entities like names, dates, locations from a sentences. For example, there's a sentence: Apple released the iPhone in 2007. So with these algorithms are able to know, okay, this is not Apple as a fruit, but it's an Apple organization. iPhone is a product, and 2007 is a date. Sentiment analysis. This involves determining emotional tone, whether it's a positive, negative, or a neutral sentence. Machine translation means translating text between different languages. Text summarization. We have a very huge text and we summarize it into meaningful small para or sentences. Common libraries in Python which are used in NLP are NLTK. It's a classic Python library for text preprocessing and linguistic tasks. Spacy, it's an industrial strength NLP library for fast tokenization, named entity recognition, and part of speech tagging. Hugging Face transformers, pre-trained transformer models like BERT, GPT, T5. Sentence based subwords tokenization for multilingual models. So real world applications of NLP is in chatbots and virtual agents for customer support, search engines where the keyword from the human based search are taken and then results are provided. Social media monitoring, sentiment analysis, trend detection, healthcare extracting insights from medical records, education. So in summary, NLP is a core technology behind modern AI systems which involve human interaction. Now let's get into the basics of this topic. Tokenization, as I mentioned earlier, what is tokenization? It's a process of breaking down text into smaller units called tokens. So there are different approaches. Word level tokenization, where in this particular example, I am taking each word and I'm converting that into tokens. In the second approach, which is character level tokenizations, I tokenize each character. Subword tokenization, for example, unhappiness, I create subword out of it and create token from it. And then advanced algorithms are like byte pair encoding, word piece, which is using BERT, sentence piece using GPT and T5. These are language agnostic tokenization techniques. The libraries for these are NLTK, Spacy, Hugging Face, and sentence piece. Now let's look at text preprocessing techniques. So the text preprocessing stands for cleaning, normalizing, and reading the text for further ingestion into an NLP pipeline. So there are different techniques in the preprocessing. One is lowercasing, where for example there is a word, I convert all of these characters into lowercase. For example, I have stop word removal, where this is my particular sentence and I remove all the stop word which are sentences like is, words like is, a, these are removed and only the meaningful sentence words are kept. The stemming stands for reducing word to their root form. So for example, here running is changed to run, which is a root form of this word. Lemmatization is uses linguistics rule to reduce words to their base form. For example, better reduced to good. Even best will be reduced to good, right? And now noise removal, for example, my text or my sentences or my paras or my raw text has punctuations, decimal tags, emojis, or special characters. These are all removed. Normalization means if I have spelling variations, mistakes, slangs, or abbreviations, I reduce all of those back into the base form. So if you say this is a typical WhatsApp kind of messaging, you are great, that's removed to that is normalized to this base form. Libraries for this are NLTK, Spacy, TextBlob, regex, Python. Summary. In the summary, we can say tokenization is the process of splitting text into meaningful units. Preprocessing is a technique of cleaning and normalizing text for better model performance. Together, these steps form the foundations of any NLP pipeline. Great. Now let's move to the part 2. So here in this particular part, we will look into NLP pipeline. By pipeline, what we mean is it's an automated series of steps which can be done in a particular environment, which can be a production dev or a particular test environment where we fed certain data and we get the output. And these series of steps can be done in a sequential manner. So in any NLP data pipeline, we have these fundamental steps. First is raw data, then preprocessing, then tokenization, then embedding or feature representation, then model training, evaluation, and deployment. So these are the fundamental steps of it. Now let's look into data collection, which involves gathering raw text data from sources such as document, website, social media, transcript. So what we do is we collect, we read, or we save text from all of these sources, which can be fed into our further models. Then the second step is text preprocessing, where we clean and normalize text for consistency. For example, lowercasing. So here we have lowercase. So this we have already explained. So all of these techniques are done. Right. Then tokenization. We have talked about tokenization also earlier. So after we have removed all of these particular stop words, lowercasing we have done. We have made our text more sanitized. Then we create tokens out of it. Right. So each word is presented as a token. And these can be word level, character level, subword level kind of tokenizations. Then we have feature extraction or embeddings. So when we look at feature extraction, there are feature extraction techniques like TF-IDF and others. And then we have more advanced semantic dense vector representation of the words using embeddings like Word2Vec, Glow, or Bird, or GPT. Then further what we do is we then once the so what this step does is it takes all of these words, right, and it converts them into features which can be fed into your ML model. ML model can be a machine learning or a deep learning model. So it can be done for the classification, for sentiment analysis. It can be done for sequence to sequence. What it really means is that you input up particular series to get a particular output. For example, you would want translation, you would want generation of text, right? So all of those kind of things are done here. Generative model, text summarization, and chatbots. Evaluation, it's a typical machine learning step. So if you already have not learned machine learning, I'll recommend you to go and do the machine learning course first to understand this further. For now, you can just understand it on a very high level, and you can later go and understand what is a machine learning pipeline to understand this better. So here, for a classification model, we use typical ML kind of scoring approach in terms of accuracy, precision, recall. So these are represented using classification, report, confusion matrices, and all. Blue score is for translation. These are more advanced scoring mechanisms, and rogue is for summarization. Then deployment, you can deploy it in NVIDIA, Azure, and other platforms. So great. So now we have explained these steps in machine learning pipeline. Now let's look at tokenization and the feature engineering in NLP. So tokenization, we have already explained. It's the process of splitting text into smaller fundamental units known as tokens. Approach of tokenization, we have already explained: word level, character level, subword level, and sentence level tokenization. Libraries for tokenization are Analytic Case, Spacy, Hugging Face, tokenizers, and Sentence Space, for which are used for multilingual LLMs. Feature engineering stands for which transforms tokens into numerical representations that capture meaning and context. Right now, there are I would say these are the basic approaches. So we have these two, which are more, I would say, frequency based approaches, where we just take these tokens and we see, okay, how is the repetition in the particular in a particular series of tokens to give them a meaning. So for example, for bag of words, we represent text as the frequency of word count. It is as simple as that. So what limitation of this is, it ignores words order and context completely. Now TF-IDF weighs word based on the importance across documents. So it is a little bit advanced than the bag of words, where what it does is it first finds the frequency of the word just like this, and then inverse document frequency AI appears in how many documents, right? So in terms of so then then it gives the importance in terms of how rare it is, but how important it is, right? Then we have embeddings. So embeddings are nothing but dense vector representation capturing semantic meaning. So what this really understands for is apart from repetitions and their particular presence in a particular series of words or a document, we provide semantic meaning to this word. And what do we mean by semantic meaning? So let's say I have king and man. So if I look in terms of these first two approaches, it's just two words. But when I go into embeddings space, then we organize these in these dense vector spaces into a particular order. For example, king and man will be closer to each other in the vector space, whereas women and queen will be closer to each other, and these two words combined from each other will be far. Similarly, global vectors trained on co-occurrence statistics. So this is again a word embedding approach which shows, okay, Paris is a capital of France, so it already knows that context is already present. Then we have contextual embeddings represent words based on the surrounding context. So we have Elmo embeddings where vary depending on sentence usage. So whether bank is here used in a river or a bank account, so it is more advanced than the word embeddings. Then it goes into more contextual understanding and the surroundings of that word also. And then BERT and GPT transformer based embedding capture deep context, whether Apple is a fruit or a company, so it goes at that level. Characters embeddings, these are more basic, I would say. Then here represent word at character level to handle misspellings or rare words. We have subword embeddings, and we have sentence and document embeddings represent the entire sentences or words as vectors, like Doc2Vec learns document level embeddings, and sentence BERT creates embeddings of semantic similarity tasks. So if we want to show a visual representation of it, let's say I am talking about input, the movie was fantastic. So this is my input. It is at a very fundamental level. Then what in the pre-processing, what I do is I move this remove all the stop word. So I think here we have not removed, but here just for information sake, this will be like this. So I will remove the, and I will have this stop word will also be removed. So I will have the movie and fantastic. So here I will have only two tokens fundamentally, which is movie and the fantastic. And then in the bag of words, even this I will remove because it doesn't give me any contextual meaning here, and even was will be removed, right? And let's see how it will look now, right? So this was the word I did pre-processing lowercase, and I did the uh, stop words, and then the tokens were created for this, and then the feature engineering was done. So this is as we had mentioned here. So this is more frequency based, I would say, representation of this vector, where I'm just showing, okay, movies one time and fantastic is one time. In Word2Vec, what I do is I create embeddings with more with the dense representation in the vector space, where I show, okay, how these words are related to each other, right? In BERT, it goes more advanced contextual embeddings for sentences, and then model predicts whether it is positive or negative. It is based on typical machine learning model. So let's say I'm using a logistic regression for a binary classification, whether it is positive or negative. So as simple as that. Now summary, we talked about tokenization, we talked about feature engineering, how it's done, what are different approaches. We have bag of word, we have TF-IDF, and then we have embeddings. Together they form the foundations of NLP pipelines, enabling models to understand and process human language. If you want to understand or go into more details of feature engineering in NLP in terms of what is bag of word, TF-IDF, embeddings, I have a different separate video for the same. Great. Now let's get into the hands-on. In the hands-on part, what we are what we'll be talking about is we'll show, okay, from terms of coding how it's done. So what we have done here is we are first importing all the libraries here. So we have this colorama, and then we have all the other dependencies. We'll just import all of this first. Let me refresh this kernel. Okay, so we are importing the libraries. And then in the second part, we are using the MDB dataset from this dataset library to import the required dataset for us. What it is doing for us is it is giving us a dictionary, and inside it that we have a list. So what is happening is it's giving, or we can call it more of a nested dictionary. So then what is happening is we are saving all of the items into this list. We are sample down for the speed optional. So what we are doing is we are just giving it sample random sampling we are trying to do here. So for random, so these are optional steps. You don't need to get into too much details of it. You will have other ways where you can directly get this other data frame, and then with the data frame you can have train test split kind of functionalities which are quite simpler. But just for the sake of it, let's understand this. Here what we are doing is we are doing random sampling here, passing the uh, passing the train indices and the test indices in terms of how where they will exactly be, right? And then from the train indices, we are passing the values here in a train text and the label text. We have tried to do some sort of exploratory data analysis here. So let's try to print this. So in train text, I have this is a list, and if let's say I'm planning to print the length of it. Let's see how many items I have 5,000 items, and for the first item I'm gonna see, okay, what is really present here. So this is the movie review. I believe this is a very good sequel, better than the first live action film 101 Dalmatians. So it has given a review, right? In terms of label, 0 stands for either good or a bad, I would say, sentiment. And similarly for test set, which will not be given into training set, but how it looks, we can see it here. All right. And now let's go into get into the pipeline steps. Now we are starting with the pre-processing step, where we will be cleaning the data, and similarly at the same time we are also doing a tokenization here. What I have tried to do here is I've tried to show it in a more visual way so that we can understand it in a better way. The steps that we are doing here is we are removing the HTML tags with this code. We are removing non-alphanumeric characters. We are normalizing white spaces and lower cases. So we are tokenizing into words. We are removing stop words after the tokenization, and then we are saving that back into this clean text. So for train, all the text is being saved here, and for test, it is all being saved here. We are taking only 5 samples here just for the showcase of it. So let's say I took the first particular text. Arguably, this is a very good sequel. And then what it did was it removed the HTML part of from it. Then it removed the special characters. Then it removed the lower casing and white spaces. It did the tokenization, removed the stop words, and similarly it went for the other ones. So it's just for the showcase purpose. So we have done for the 5 items. Now what we'll do is we'll run it for the entire data set. So our stop words are for English. We are using for tokenizer, we are using regex exp tokenizer, and all of these words are being saved. They are already saved here. Now exactly what we are doing. So what we are doing is we are creating in this pipeline what we have done is we have used the TF-IDF vectorizer, and then so TF-IDF, how it works is it converts text into numerical features. Term frequency is how often a word appears in a document. Inverse document frequency means how rare the word is across all the documents. Based on these two, it shows how what is the weightage, right? And common, so result is that, for example, common words get lower weight, rare informative words get higher weight. Now let's look at this. This we are creating a pipeline here, and in this pipeline we have TF-IDF as a vectorizers. We have provided the hyperparameters into it. Maximum features will be 20,000, not more than that. Ngram, what we are doing is we are using by unigrams and bigrams. What it really means is we will take one word at a time, and also the 2 words at a time to be fed into this vectorizer. Sublinear TF log scale term frequency. So it's I don't have full idea on this, but this is a hyperparameter here, and then normalized vectors is L2. Right, and then we are using logistic regression, and for that we have hyperparameters as maximum iterations as 1000, and then we have these 2 other hyperparameters. Then what we are doing is we are creating our pipeline, training the sentiment classifier. When training is complete, it will show this. The TF-IDF will work, and then the other steps will be shown. So let's run it. So it is explaining TF-IDF what it does, result common, how it is given the weightage. So it's more of frequency based vectorization. It's not embedding per se, but at least we are giving giving weightage to our words in terms of their frequency. And then logistic regression is ready now, and then we are running the logistic regression model here. Okay, so the model is also trained. Now what I've tried to do here is I have, so since we have 20,000 odd features here, I have tried, what I'm trying to do here is it will not be possible to showcase that here in terms of that complex graph. But what I have tried to do is, with the PCA algorithm, I have tried to decompose it into three feature sets and then show, okay, how these words look. Right, so we can see here, trying hard is here in this vector space, dash vector space effects is here, enjoyed movie is here. So you see how far they are from each other. And then story, you can see quiet is here, and then some of the word like director, and everything movie, and then a lot of other words like demand and all are close together. So in this, in terms of their frequency and how they are quite close to each other. Right, and then in terms of model evaluation, what we are doing is we are using, since it's a typical classification problem, we are using classification report to show precision, recall, and upfront score. If you're not aware of these terms, it's okay, you can go into the separate lecture on the machine learning series. Now here it has tried to show the sample, so it has taken the test which we had created earlier, and based on that test it is trying to predict. So the first one, we have created, taken three samples, very resistible but ultimately harmless film version of the children's literacy. So this is positive. It could have been good. It has second said negative, and then it positive. So it's, I mean, on the first iteration, it's quite a good accuracy that we have got. We can make it more better with further training, but yeah, it's for quite well. Now this, I mean, it's an advanced topic, but I'll just try to touch upon the basics of it. So here what we are doing is using Spacy. We are doing the name and recognition. We are loading the embeddings from here. And then what we are doing is, using this particular one, we are trying to predict the, or tag the entities. As I had mentioned earlier, entities are nothing but named entities are nothing but different classes in which we organize the series word or series of words. For example, Mary Poppins is a person, 1964 is a date in this particular comment or sentence. And then James Madison is a person, the railway children is a event, Amazing MR is a organization, some time ago is also a date, Anchor Bay is a FAC. So these all are different kinds of classes. UK is a GPE, right? And then similarly here, right? Right. So that's it on our hands-on series. Now let's get into the embeddings part. So what are word embeddings in NLP? Word embeddings is a dense vector representation of words in a continuous vector space. So what it really means, unlike one hot encoding like spares or high dimensional, uh, embeddings capture semantic meaning. Words with similar meaning are closed in vector space. What that really means is that, uh, unlike TF-IDF or bag of word, the embeddings give semantic meaning also to the words. Each word is mapped to a vector where D is the embedding dimension. Semantic similarity is measured using cosine similarity or the Euclidean distance. Cosine similarity is how words are similar to each other, and Euclidean distance is in a vector space how the distance is measured between two words. So what is the scientific basis of it? It's the scientific basis is dependent on the words that occur in similar context tends to have similar meaning. Embeddings are learned by predicting context words given target word. It captures syntactic grammar and the semantic meaning. So king and man, as I had mentioned earlier, king man will be close to each other and women queen will be close to each other, right? Different libraries. Gensim is popular for Word2Vec and FastX. TensorFlow, PyTorch for custom embeddings, layer for deep learning, Spacy for pretend embedding integrated with NLP models, Hugging Face transformers, contextual embeddings, Bird GPT. Word2Vec has two sub approaches. CBAO, continuous bag of words, which is used to predict single word from a group of words, and skipgram is used from one word we predict multiple words. Globe is a global vector trained on co-occurrence metrics, so it's a quite advanced and a large scale kind of embedding model. Fast text subword embeddings handles rare words misspellings. Contextual embeddings like Ilmo, Bird, GPT embeddings depend on the sentence context. So let's talk about Word2Vec. So Word2Vec has two particular subtypes, CBAO and the skipgram. CBAO is continuous bag of words, predicts target word from the surrounding context words. For example, the quick brown fox jumped over the lazy dog, right? So let's say lazy is not there, so it will be able to predict lazy from the series of sentences. It works faster, works well with the frequent words. Skipgram is a different kind of algorithm. So it what it does is from one word it tries to predict the word. So it captures fine-grained semantics better for rare words. Comparison table, you can see where it is used what. Right, and here we have tried to show in terms of simple invocation as to how these embeddings work. For example, from gensim.model import. So this from gensim we are importing word2vec. From analytical tokenize we are importing word tokenize. So first we are tokenizing our word, right? And then once tokenization is done, we are feeding them into this embeddings from word2vec and for the skip gram, and then we are trying to show in terms of similarity scores how they are, right? So they are similar, but the approaches are different in terms of how the predictions will be done using this. Great. So that's it in the first part of the NLP Basics series. If you like the video, if you it was informative, please like, subscribe, and share.